Hey everyone, so in this video we are going to look at creating the barrier between the top and the bottom of the ship. The barrier is going to be comprised of individual blocks. The blocks will be traveling from left to right. When the block gets to this end cap, it will immediately be put over here and then it'll continue on its way. Now that movement really should be imperceptible to the player because we're trying to create the illusion that you've got this barrier that's traveling along the circumference of the ship. So there's a couple things we have to do to make that happen. So in a 2D environment, there is no meaningful use of the z-axis. There really is no depth. So to fake depth, what you have to do is use order and layer. So by default, every object has a 0 order and layer. With the higher the number, it will cover everything in lower layers, okay, or lower order within the layer, I should say. So what we're going to do is, since everything defaults to 0, we'll just bump these up to 1. So the two end caps get bumped up to 1. Also, this is too small to cover a block, so we redrew the image, again in external paint program. You don't have to delete your current ones, you can just drag and drop it, replaces the image. Now, as it turns out that this size still isn't quite right, so you will see some flicker of the block over here, but again, as long as you understand the principle, you can adjust it to make it work for you. Now, the second thing, we need to detect a collision, which means this object needs to have a box collider. So add component, physics 2D, box collider. Now let's zoom in. I'm going to turn this to a trigger too so I don't forget. See how the collider line is right here? Well, that means the block will be right here, touch that and move, which means you'll continue to create a gap. We don't want to see a gap. We want it to be imperceptible that it's moved. So what we're going to do is we're going to click on Edit Collider and we're going to push this barrier in. So see all this dead space now? It's acting as if there is no collision occurring. So the block will be hidden by this space and not move until we get to here. Okay, so that should finish preparations for the ship itself. Now we can get into making the barrier. So we click on our box solid, go to Game Object, 2D Object, Sprite, and we'll just call this Barrier. And then we'll just move it over. And this is going to have, since it's white to begin with, you can change the color. So let's make it like, say, a bluish color. If you want to be really fancy, I'm not going to show how to do it, but if you want to be really fancy, what you can do is if a block can take multiple hits, you can change the color per hit. So it starts as blue, turns yellow, turns orange, turns red, and then gets deleted. You could do something like that. Not going to go that fancy with that. That's not how the original game worked, but just want to throw that out there that you can indeed maintain the a color for each one independently as well as how many hits remain. So let's move this over to its default position. It should be negative 3.5 and positive 1.485. Nothing magical about those numbers. It's just where it lands on my project. Your project might be different. So if it is, don't worry about it. And it does look like that would appear ever so slightly on the screen. So like I said, you can tweak the location of the end cap. So it kind of covers it up a little bit more. Okay, so for our barrier object, it needs a few components. Add component, physics 2D, rigid body 2D, that allows for motion. So that's going to allow it to move from left to right. Gravity scale will be 0, so it would drop down. And then add component, physics 2D, box collider. So it also needs a box collider. Set that as a trigger. Did I set this one to a trigger? Yes, I did. Okay. So now it has almost everything that it needs. Now it needs a script that will have it travel from left to right. So we need to have a right click, create, C#, and we'll call this, say, FF for force field. I'm not quite sure why this opened on its own. It didn't even open the script. Gets a little glitchy like that. Okay, so again, we can delete this. This is just a remark. This is just a remark. Again, you can tell by the double /. And in the start section, we're simply going to say get component rigid body 2D. Again, make sure you're using the 2D version. We're going to give it velocity equals new vector 2, and we're going to have it say travel +2 and 0. So 2 along x, 0 along the y. Also, we need this to detect collision. So collision with bullets, which we can hold off on, but definitely collision with the barrier. So what I did when I was testing, I renamed this object. So I just put an R at the end. So it's NCAP R. You can rename it whatever you want. Now, we've looked at detecting collisions based on tag. You can also use object name. I'll just show you that so you have another tool in your toolbox. Using tag is typically better, but I'll show you how to use name. So on trigger, enter 2D. Again, must be 2D. Get rid of collision if you want. Change it to other. Again, to reinforce that it's referencing the other object involved with the collision. And if other dot name equals NCAP R, then we want something to happen. We want its position to be moved back to that starting position. That starting position, so get component, transform, position equals new vector 2, and it was -3.5. We have to drop in an F since there's a decimal, and I believe it was 1. Don't remember. 1.485. So basically wanting to reinforce that you need to be consistent with that position. So again, for your project, you might be using a different position. For mine, that's how it settled out. Okay, so let's test that because I believe that is enough to make the block travel, collide, and then move. And what I do not attach the script. I did not attach the script, of course not. All right, so the barrier object will attach the script, and let's do that again. Here we go, and let's see if it moves over. It did not. Why not? NCAP R has a box collider. Oh, I misspelled it. Sorry. There we go. A lot of times I'll edit out little mistakes like that, but it happens. Sometimes you forget to attach a script, and sometimes you simply do a typo for a value. So it's important to know that sometimes it's as simple as a mistake as that. Now what we're going to do, we're going to create a GM object. There's absolutely nothing special about a GM object. In fact, calling it GM is only meaningful to you, the designer. The whole point of the GM object is that it's meant to hold coding and functionality that really isn't readily associated with just any one object. And so you use this object to basically collect and kind of be a holding place for all this code. So game object, create empty. GM, again, GM means nothing to Unity, just you. And it's going to have, we're going to add just one additional component, and that is a script. Now, I typically don't write the script ahead of time, but I did this time because I didn't want to make any mistakes, and I was making lots of mistakes when I was testing this. So right here, game flow, that's what I'll typically name a script that has to do with, say, spawning, instantiating, environmental controls, things like that. So we're going to take that script, we're going to put it there. I'll explain that in a second, and we'll open this up. So, in game flow, this is basically we're creating a linkage to the barrier object, which we haven't done yet. But we're creating a name. We're saying, okay, barrier obj is going to be the reference name for the barrier object. So by doing this, you're making the GM object aware of the barrier object. Once it's aware of it, it can do something. Well, if it's aware of it, it can spawn it. It can instantiate it. So the next two lines are that. The first one is what's known as a for loop that used to be called for next because you used to have put in the word next years ago. So let's break down what this says. There are three things it's doing. First, it's establishing that you're using a float type variable. This is the name of the variable. I'm calling it xPOS because that's what we're going to use it for, is for the x position of the object. So it's a float type variable with the name XPS, and this is its initial value. And again, since there's a decimal, you have to put in the letter F. Separated by a semicolon, this is the second thing that it is saying. It is saying that that variable that we just declared here, keep doing this as long as it's less than positive 3.5F. And the reason why that works out is because the ship is basically symmetrical. So like this over here is roughly 3.5, and this over here, this is roughly negative, and this is roughly positive 3.5. And then the third thing says, as long as this is true, increment by this amount. Nothing really magical about this. It's just what worked for my object. So my square object, through trial and error, I determined that this was the amount of space that needed to be to avoid any gaps while this is running. So you might, depend on the size of the object you're using, you might have to use a different number. As long as you understand the core principle, you're declaring what the variable is, the type, the name, the value. You're saying what the range, the upper limit should be, and then how much to increment it by. So what the for statement is saying is, while that is true, we want you to do something. We want you to instantiate an object. Again, instantiate, spawn, instantiate. Those words should be synonymous to you. And the instantiate command has three arguments. What is being instantiated, where it's being instantiated, and the rotation of the object that's being instantiated. What's being instantiated? This. So we created a name so as that the GM object could reference the barrier object. So it's saying instantiate that barrier object. Where? Well, we're going to give a vector to position. This calculation that's been happening every time, every cycle, this number is going to change by 0.28. So it's going to keep moving to the right by 0.28, but the same height. So my apologies, I usually don't have this typed out ahead of time. I just didn't want to mess this up. So again, this is creating the cycle. This is what's happening during the cycle, and it's utilizing that value that's being modified during the cycle. Now what we do, we have GM, we have our script, so there it is, barrier obj. So right now barrier is in the scene. We don't want it to be. We want to make it a prefab. So we drag, drop it, it's the prefab, delete it from the scene, go back to GM, and then we put our prefab there. Now if I haven't forgotten anything, that gets us just about to where we need to be. We haven't done the detection of the bullet yet, but let's see how this runs. So you do have a little bit of a gap there. Like I said, we're trying to avoid that, so you would have to move this out a bit more. So let's go to our end cap. Actually, I'm surprised it's showing that much. Let's move that out. There we go. Just moving it that much made a difference. And actually, I really thought there was going to be a little bit of flicker here, but it looks okay for the moment. Now, the other test is once we start knocking holes in this, because right now it doesn't really look like it's moving. So what we can do is now we detect for the shot. And for that, we go back to the force field script. Right now we checked for the end cap name. We can also check in the onTrigger intersection if other.tag equals, I believe we used shot, didn't we? And then just destroy. So destroy game object. Just going to do a double check over here. And I don't think I pointed out, but since this is in the start section, it only happens once, so it's not like it's recreating the barrier over and over again. So the force field is now checking for the shot tag. Let's make sure that shot is using that tag. It's been a long morning. I don't remember. Yep. Okay. Excellent. Okay, so I think that does it. So that gives us our barrier, and it's fairly seamless and actually looked a little bit better than I thought it would because I didn't think this would quite cover it up, but it does. About the only thing that's really left, you could add scoring, but that really wasn't the idea. I wasn't trying to do a full game here. I was just really, again, trying to show you how to make a destructible, or should I say a mothership that has like different layers of destructibility. So I think that should about do it. If you have any questions or any other requests, let me know. But I think that this series has basically reached its conclusion. Again, unless there's something specific you want to see. So I hope this was helpful, and I hope you have a good day.